Hello class, in this video I will be reviewing the average rate of change, then applying the power rule to find the derivative of a function, and applying the derivative to everyday business concepts. Let's begin. Notice here I have a couple of basic rules for derivatives. I have the constant rule, the rule for coefficients, and the power rule. So I'll be going through each one of those rules as we go along through the problems. An energy drink company notices that their profits, in hundreds of thousands of dollars, could be modeled by the function p of x, where x $100 are spent on advertising and x is between 0 and 5 inclusively. What is the average change in profit when the amount spent on advertising increases from 100 to 200? So this problem is asking for an average change in profit. So we're going to use the average rate of change formula. But we need to be careful because we're not going to evaluate the average rate of change using 100 and 200 because x is in hundreds of dollars. So what that means is that when x is equal to 1, that represents the number 100. When x is equal to 2, that represents the number 200. So the average rate of change can be found by evaluating p of 2, subtracting p of 1, and then dividing by 2 minus 1. And we can do that on Desmos. I've gone ahead and typed the profit function into Desmos, and I evaluated the function for 2 and for 1. So this is equal to 0.3 minus 0.16 divided by 2 minus 1. So profits will increase by exactly 0.14 $100,000. Part B, determine the marginal profit function using the power rule. So the problem is asking for marginal profit, and you measure marginal profit by taking the derivative. So we want to find the derivative of the profit function. And if we want to find the derivative, we're going to have to apply the power rule. However, in the current form, this is a product. The profit function right here is a product. And to apply the power rule, we want single variable terms with real number exponents separated by plus or minus signs. What's nice about this problem is that we can multiply all of those factors together to get the form we need to apply the power rule. So we're going to do that. The profit function is equal to negative 0.01 times x cubed minus 15, sorry, not 15, minus 2x squared minus 15x. Now, I'm not going to multiply the trinomial by negative 0.01 because it's actually easier to take the derivative of this function in the current form. Now we're going to apply the power rule. The power rule states that if you want to find the derivative of x raised to the n power, you're going to take the exponent and make that become the coefficient, and you're going to subtract 1 from the exponent, and that will be the derivative. So since the exponent is 3 in the first term, the coefficient for the derivative will be 3. And then 3 minus 1 is 2. 2 times 2 is 4, and then 2 minus 1 is 1, And then the derivative of negative 15x will be 15. And there is the marginal profit function. Part C. Find and interpret the marginal profit for the following values of x. X is equal to 1. So we want to find the marginal profit when $100 is spent on advertising. So the problem's asking to find P prime of 1. So I'm going to go into Desmus. And I'm going to type in the marginal profit function. And then we can evaluate the marginal profit function when x is equal to 1, and you get 0.16. And what does that number mean? That means when the amount spent on advertising increases from 100 to 200, profit increases by approximately $1,000,000. Now we'll do the same thing for when x is equal to 4. So I want to find the value of the derivative at x is equal to 4. And that is negative 0.17. And what does that number represent? And what does that mean? Well, that means when the amount spent on advertising increases from 100 to $200, profit decreases by approximately $0.17 And the last part. Determine the amount of money spent on advertising that would produce approximately no increase or decrease in profit. So the problem's asking for approximately no increase or decrease in profit. So that is when your change in profit is going to equal 0. So the derivative is going to equal 0. And we're going to want to find the values of x that make this derivative 0. And to do that, you're going to have to factor that trinomial. And that factors as such. Setting 3x plus 5 equal to 0, you get x is equal to negative 5/3. And that doesn't make sense because we're not going to spend a negative amount of money. So we're going to ignore that solution. And then you get another answer of x is equal to 3. So when 300 is spent on advertising comma a slight increase or decrease in spending will result in approximately no change in profit.